The objective of this tutorial is to work out the area between a curve and a straight line. We will apply this rule, integral y1 minus y2 dx. So the higher curve, which is in this case the straight line, minus the lower curve, which is y2, where the x starts at A and ends at B. Look at this example. The diagram shows a sketch of part of the curve with the equation y equals x into 4 minus x and the line with the equation y equals x. So here we have a sketch which represents a parabolic curve and we have the equation. Also we have a straight line which has the equation y equals x. Find the area of the region bounded by the curve and the line. So we need to find the area between the curve and the straight line. This is y1 and this is y2. So y1 is x into 4 minus x and y2 is x. Before we find the area, we need to define where these points intercept. The first point is at 0, so it is here. Now we need to find the second point. In order to find it, we say y1 equals y2. y1 is x into 4 minus x equals y2, which is x. Of course, here we expand. X times 4 is 4x. X times minus x is minus x squared equals to x. So, minus x squared, here we have the 4x, and we take this x to the other side, so minus x all equals to 0. Therefore, minus x squared plus 4x minus 1x is plus 3x all equals to 0. Remember that this is a quadratic equation which equals to 0. The easiest way is to factorize. The common factor is x. Multiplied by minus x plus 3 all is equal to 0. The first value is x equals to 0. As you can see, we already have it on the sketch. Now the second value, minus x plus 3 equals 0. Minus x is equal to minus 3, so x is equal to 3. Now we found the upper limit of x. That means x starts at 0 and ends at 3. This is where the two curves intersect. After finding the intersections or the limits of x, we need to find the area. Okay, so here we will rely on method 1, which directly uses the application of the rule. Area is integral dx. X starts at 0 and ends at 3. Then we write the higher curve, which is y1, minus the lower curve, which is the straight line y2. So, integral 0 to 3. Now we substitute y1. We will multiply directly. 4x minus x squared. Minus y2, which is x, dx. Okay, now let's continue. Integral from 0 to 3. We will organize this form. Minus x squared plus 3x dx. We simply wrote the higher curve minus the lower curve. Now we do the normal integration. We put the square brackets, so we will start like this. Integral for minus x squared is minus x to the power 3 over 3 plus 3 x to the power 1. The integral for it is x squared over 2. The boundaries of x are 0 and 3. We substitute the value 0. So, minus 3 to the power 3 over 3 plus 3 times 3 squared over 2. Now for the lower limit. First, we put minus. The value here is 0, and both have x. So if we substitute, the answer will be 0. That means minus 0. So, minus 27 over 3 plus 27 over 2. So we have minus 9 plus 27 over 2. The common denominator is 2. That means minus 18 plus 27 over 2. The final answer is 9 over 2, or if we want the decimal form, then it is 4.5. So the area between these two curves is 4.5. Look at the description. First, find where the line and the curve cross, which is the intersection. So the line cuts the curve at 0, 0 and 3, 3. We only care about the values of x and not y. The area is given by the integral y1 minus y2. So we use the formula with curve minus line since the curve is above the line. Then we simplify the expression in order for it to be integrated. And finally, we found the area, which was 4.5.